I'm going to finish up this part on tornadoes by talking you through a couple of ways that meteorologists can use equipment to understand what's going on the ground related to tornadic activity. But I will say that I've been to a few National Weather Service severe, I don't know what they call it, but training sessions for actually understanding severe weather. And they will say that if you're willing to help the National Weather Service out, a good resource to them is to have you actually boots on the ground to say exactly what you're seeing. I mention this because the things I'm going to show you only go so far. So you're probably familiar with just like regular old radar. Regular old radar tells us precipitation, where the precipitation is happening. It's a map, right? It kind of has the colors going on. Well, Doppler radar actually gives us something a little extra. Doppler radar counts on precipitation occurring, but it actually uses the Doppler effect, and I think I talked about the Doppler effect back when we talked about in physics, when we talked about waves can be shortened if something's moving towards you, and wavelengths can be lengthened if something's moving away from you. So this same sort of thing actually is applied to sending out a signal to hit precipitation. And if that signal comes back to you more and more quickly, that's then that actually will give a shorter wavelength, and that means that the precipitation is moving towards you. If it actually becomes back more and more delayed, a longer wavelength means then that that precipitation is moving away from you. So Doppler radar is not regular radar. Doppler radar actually gives you motion of the precipitation. So I'm going to show you some images. Doppler radar then, in order to spot a tornado, what they look for with Doppler radar is kind of a quick come this way, go that way. I don't know how to describe it. I wish I could kind of show you. Come this way, go that way, in a short short location. So for instance, this up here, let's see, I wonder what color will show up. Purple, try purple. Okay, no, blue, that's better. See where it says tornado? So it's a tornado signature. If you know what you're looking at, kind of that little coupling of red and green right there, that's actually what they call a tornado vortex signature, or TVS. If you listen to and they don't get, weathermen are so calm. I don't know how they can stay so calm when things seem so out of, crazy scary. But the calm weatherman will say, well, there's a tornado vortex signature as indicated by Doppler radar. And like I said, they can see the rotation by kind of the quick swings of the colors moving toward and moving away. The other thing, or another thing that meteorologists can see is back to their regular radar. They can actually see something that's kind of called a hook on their regular radar. A hook on their regular radar. And since radar is a type of echo, they call it a hook echo. So I don't know if you can see it, but it kind of does look like, let's see, what color did we say? Kind of like this, kind of like a hook. Okay, if they see that, then kind of in the vicinity of the crooks of the hook, okay, that's actually where their severe weather is. In the crooks of the hook, in this hook echo, this is the hook echo, they might see a shaft of hail falling from the thunderstorms. Okay, so these coupled together, the tornado vortex signature with Doppler radar and the hook echo with regular radar, actually shows that that we quite might have a tornado there in that location. So I've got a couple other examples, right quick, of the pairs of this is regular radar, okay, and to me this looks a little blobby, but there's a hook echo, and right here's the hook, okay, and the TVS, tornado vortex signature. This is actually one of the famous tornadoes that so here again, another pair, and listen to see if you hear them during severe weather. I can almost kind of see that the tornado vortex signature there. This one says Moore, Oklahoma. Yeah. There you go.